Kids get on the drip. 2 hours in the morning, 2 hours at night, 2.5 days, then I came home. I've taken it in the hospital, they give you 2 injections, give you these tablets to them, these things are awful. And it clips. And it's still so she has, she's very good. So if I'm not very well, she's always.
No, I got it.
That's why I didn't go to bed early.
All right.
We've got something.
Here we go.
Seem to be working?
Perfect.
This will work.
And we got Brave and we have Rich as well.
Okay, guys.
Rich is trying to steal my thunder.
Yeah,
I get the live experience.
it doesn't get any better than this. This is peak beard for me.
Yeah.
I think it's the Irish in me that, I think the Irish keeps it in check a little bit. So, well, great. Well, welcome, folks. This is, it's still online. It's still virtual, but we're 3 or 4 of us are in person. Yeah. So this is kind of a first for this. It's pretty cool. So, Sonia, kick us off. Give us a little background, and we'll get talking to folks.
For sure. So we are live streaming from Lubrication Expo 2025 in Detroit. Today it's not that cold, so that's pretty good for me.
Yeah.
There's an amazing show so far. So much good conversation, so many speakers, so many, very interesting things happening. We're going to get through some stuff with Rafe and Rich. They're going to show us some things live as they do their demo from the Lubrication Explained booth. I know you have Greg joining us in.
Yeah.
And he's going to help us out with some things as well. But this is going to be an amazing session in terms of actually those who could not get to go to Lubrication Expo or could not attend in person. We want to try and bring something to you. So at least you get a little bit of a feel for it without the cold. But you get a little bit of feel for it and you get to see the sights and the sounds of Lubrication Expo this year. So, off to you.
All right, great. Yeah, the sights and sounds for sure, Rafe, right? There's a lot of activity, a lot of traffic. We've been able to talk to a lot of folks. And for me personally, one of the exciting things is the conversations that are around grease right now, right? Because on this part of the podcast, let's say, Sunny and I have been really focusing on grease just around the world. And then Rafe, on your podcast, it could be something new every week, right? Or every time you do this.
Yeah, exactly. So, for me, the conversation that I've been trying to have with some of my customers, and I'm actually live on the Lubrication Explained YouTube channel as well. So hi to the guys that are watching there. But for me, I think the challenge is, everyone understands the importance of oil to reliability, or at least they're getting there. Everyone understands that grease is just as important. Right, so when you ask, well, yeah, they're both lubricants, it's just that one's an oil, one's a grease, just as important. Great. Who's doing oil analysis? Everyone throws their hands up. Who's doing grease analysis? Virtually no one. And the small amount of grease analysis that is being done in, whether it's in the field or in the labs, the quality of it's also pretty low. Generally what I'll see is just elemental results, and that's it. Right, so when, Rich kind of started off with the grease thief technology, I'd kind of been keeping my eye on it going, I want a piece of that, right? and now I get my hands on it.
Yeah, so today, and at the beginning of this conference, I've brought some equipment, some instruments, some sampling kits for Rafe. Here is the upside down grease thief box.
Oh no, there we go.
And my wife's note that I didn't forget it, so that I bring it to Detroit so we can actually use it. But I'll start, we'll do an unboxing. We'll do a live unboxing. This is unrehearsed, so anything can happen.
So, all right, so this is the kits, right? So this is, again, going back to, grease analysis and why people are sort of maybe unaware of it. a lot of the objections to doing grease analysis have got to do with sampling, right? People have this feeling that I can't take a representative sample. And so what's the point of doing sampling if I can't get something that's representative? Not knowing that there is actually an ASTM standard around grease sampling. And these actual grease thief, well, I'll try and open it up.
Yeah.
These kind of sampling kits are a way that you can do sampling according to the ASTM standard.
That's right. That's right.
So what? I don't even know what I'm looking at here. What am I looking at here?
Let's start with the first one out of the box.
Okay.
Okay. So what you're seeing on that end is the color coded. We've done some color coding for the purpose of just sharing with folks. But what we have, if you flip that over, Rafe, you'll see the title at the top of it, right?
All right. So for my guys, grease sampling kit, and over here, same thing.
Yep. And this one is kind of our generic kit. It's called for pillow block kit.
Oh yeah, it has that sign down there.
Yeah. And so it would represent the sampling challenge of grease is going in, it's coming out somewhere. It could be on the face of the bearing. It could be kind of an open situation, like an open gear grease or something like that. But the grease is presenting itself to you on the exterior of the machine, and that's what we put into this category of the pillow block kit. And if you open it up, I'll show you the components that are inside.
How am I doing this? Which end?
This end. There you go. So it's in a sealed container.
Aha.
And just to keep everything clean up until the time we're ready to use that. And let's look at the parts that are here.
Hang on.
Yep.
Here we go.
Okay.
All right, so you can already see that's kind of some kind of spatula.
That's right.
This looks like a 7-Eleven straw that
Something
you
like
get in
that.
a Slurpee cup.
Yeah, but this is a high-tech Slurpee straw. Yeah. And generally what we'll use this for is that the wide side or the spoon side gets used to pull the debris, the dirt, the external material away from your sample zone so that you get a shot at the grease that's underneath. So you would do that, then you would flip it in your hand and work this end to actually capture the grease that you want to sample with.
Oh, okay, yeah. So this is kind of like getting away the old crappy grease?
Yeah.
And this is like the grease that I
the
actually
good stuff
want.
that I want to test underneath, right? And so from there, we've got a glob or some of it onto the end. Now we're going to do an assembly here with these two components. Some will recognize this as the grease thief that they've seen before. We have, again, some color coding tape on there, but I'm going to take the yellow cap off and move the piston to the end. So you have the open end of the grease thief here, and that red piston is sitting at that end. And this is the new piece we have, which is the GT filler. So it takes the place of a syringe or something like that might require more plastic, and we use this to get the grease into the grease thief that has a smaller opening here. So just to start this, I'm going to push this open a little bit. And it's got two parts. The first part is kind of like a funnel, and you can see that it's narrowing it down into the opening that will work on the grease thief. So I just kind of screw that on there, and now I'm ready to take that sample. With one hand, I have this. The other hand could then be depositing the grease into that cup.
So I've got high quality grease here, and I'd sort of like do this, right?
Yeah.
Get as much, fill up this cup as much as possible.
Well, fill up minus kind of like a cone in the middle.
Okay.
Yep. And can you hear us okay? Is this still good?
Yes.
All right, super.
Still good.
And so this is the plunger section that's going to follow that. So when we get that filled up with a little bit of a cone cavity in the middle, then that goes over the top and engages. And since we don't have any grease in front of us right now, you're not going to see this, but now with one hand, by pressing that down, it's going to transfer into the grease thief, and it will be pushing that piston down as it fills with grease. So small amount of plastic. We're trying to stay conscious of single-use plastics and things. We've reduced the amount of plastic by 2/3 with this development over the large syringes that we used to use. Now you'll have a grease thief full of grease. You remove and dispose of that GT filler, and then the cap comes back to seal it up. Now to ship it, the kit also includes a shipping tube where we can drop that inside, put a label on the outside of it, put a barcode, what have you, and now it's ready to go wherever you're taking it to analyze.
So I guess the oil analysis analogy for this one is that usually when you take a sample bottle you usually have to put it inside another bottle for shipping.
Yeah, like
right?
an overpack or something.
Yeah. So that's kind of what I guess this test tube is for, right?
Sure, and it's very similar because you don't want like the cap to get grabbed and loosed in the oil situation. Here, you don't want this to get compressed and push the grease back out again.
Yep.
And you want to keep the outside of it clean as it ships and gets back to your analysis location.
Okay.
Yeah.
So
So
this
that's
is-
one. That's the pillow block.
All right.
Yeah.
So now we probably don't have to go through all of them,
No.
but you've got a whole range of different sampling kits in here.
Yeah.
Oh, hey, this is a cool one. Why don't we do this one?
Okay.
So some of them are specific for applications, right? So this is grease sampling kit for a wind turbine main bearing, right? So again, wind turbines, if you think about it, extremely expensive assets, worth a hell of a lot of money.
Yeah.
The pitch bearings are, let's say, unusual in that they never really fully rotate,
That's right.
right? So it's only a small amount of rotation.
They're oscillating, really.
Yeah.
Yeah.
And so you've got a dedicated kit for those. So
Yeah.
what's
And
different about this one versus?
Well, the internals are very similar. The instructions on how you use it with the main bearing versus the pillow block bearing is going to be the fundamental difference.
Okay.
And by putting it all together in one package, when it gets to the end user, this is all they have to take. The instructions are there for them. It walks them through the process on obtaining a representative sample. Not only does this adhere to the ASTM standard, ASTM D7718, but a few years back, the American Wind Energy Association issued a number of working standards for them called their best practices, and there was one specifically for this. So it conforms to the AWIA, or the wind industry's standards for sampling as well.
Awesome.
Yeah.
All right, so that's one that's dedicated to the wind industry.
Yep.
While we're in here, we might as well do a couple more.
Sure.
We don't have to open up all the packs, but we've got, what's this one?
Is that another wind one?
Oh, another wind turbine main bearing. These are all nicely color-coded. Grease turbine, again, wind turbine, but some that don't have access plugs. Do you have a robot grease one in here?
I think so.
Here we go, robot
Yeah.
drive gear.
Right.
So if anyone has seen those kind of like big, kind of 6-axis robot type things that you might see in auto manufacturing plants, packaging for the food industry and things like that, this would be something this is an area where I'm kind of passionate about it and really want to drive this in Australia, because people have these kind of packaging robots. No one ever tests the grease, right? And so they're losing out on a huge amount of information about the reliability of a very, very expensive asset, right?
Yeah.
Cool.
And with that, yesterday, the first day of the conference, I was teaching a food processing lubrication certification class. And with that, we talked about all kinds of different components. Robots did come up because you do see them in handling applications. A lot of time it's in the palleting and things like that, but sometimes it's actually on the line. And so you need to think about food grade greases and the impact of how they're being used in robots as well. And this is a way to sample them, get that data. Yep.
That's awesome.
So at the end of the box, we kind of have a rundown of the different kits that are available. We kind of checklisted these just for the purposes of bringing here this week. But we've got the pillow block, the electric motor, the MOV gearbox. So gearboxes in general, but specifically around motor operated valves and sampling for that. We got the wind turbine, the robots, like you say, and then kind of a catch-all called the Grease Thief Slim. Now, I can demonstrate that. It should be in that orange case that we brought along at the front, and we'll see if we can grab that one and show that a little bit.
So this is my version of like Nerd Christmas.
Oh boy.
Ugh.
So, I'm not sure if you can get the screen a little bit bigger.
Like,
because it's showing like a side panel view rather than a
Oh, you're in portrait rather than landscape. Maybe if we
in the middle of the presentation, change it? What's that going to be?
could try it.
Yeah?
We could always flip it the other way. Is that better?
not really. A little bit.
Yeah.
A little bit. Oh,
The screen is blank, so I think it's probably because we're doing it from the phone.
yeah, so who...
This is a nicer version though.
Are you able to spotlight?
Super Spike.
Are you able to spotlight Rich's picture?
Oh, that is great.
All right.
Good.
Okay. So nicely boxed in a pellet. Whoa. All right. So Okay, continuing with Nerd Christmas.
Oh yeah.
So this is the Grease Thief colorimeter, which, okay. Remember, we've traditionally always said the color of a grease does not matter, right? And most of the time what we're saying, the reason we're saying that is because there is this conception that, like, I don't know, red greases are better than blue greases, are better than green greases. Vast majority of the time, the actual color of the grease that you purchase does not matter, because it's just a dye. Most grease is pretty like beige, kind of boring looking, so they put it in for branding purposes. Now, in fact, we've kind of come full circle and found that in use, the color of the grease actually does matter, in the sense that if we look at the grease color, it can give you an indication of grease degradation. Right. So this is all Rich, right? I haven't done any of this work, but Rich is the brains behind this, right? So helpfully, user manual. All right. For a second there, I thought these were socks. You're going to have to tell me how the hell to use all this stuff.
Yeah, sure thing. So, this is kind of a custom soft case for metal spacers.
Okay.
So a key kind of principle here for doing colorimetry is that if you know the Beer-Lambert law, which says that as you pass light through a sample, it will absorb that light proportional to the concentration of materials that are present, and the path length becomes very significant. So that's the case in grease too. If we really want to define the color of a grease, we have to define the path length of which we are illuminating it and then measuring the absorbance of that path length. So this allows us to, these are spacers here that have different, you got A, B, C, D here, and the A spacer would be used to zero out the device that we're going to show in the middle, and then by removing that spacer and working with the other spacers, we can create a grease path length of 0.35, 0.10, and 0.05 mils, okay, or inches, right? So, so that'll make more sense when we pull out the main assembly here.
Okay, so, and while Rich is doing this, I should explain, in terms of unboxing, this is not like an advertisement. This is actually my unit, right? So I'm going to be setting up a sort of like a mini Grease Thief lab in Australia for people who want to get their greases tested in an industrial setting. That's why we're doing this, is because Rich, who invented all of this kit, is kind of explaining to me in real time
how you use your stuff,
how all this stuff works. This is kind of like my introduction to the user manual,
right?
And so that's why we're going through this exercise. I thought it would be kind of fun to do it in live.
This is great.
All right, so what have we got? What is this?
Yeah, so what is this in real life is this is a device. The core of this is a device that's used to reload shells. Okay. So it's a reloading device, but we've taken the mechanism and we've done quite a number of different things here. Number one, we've taken what's usually a load cell area here, these springs that can press and then would move a dial indicator. We're kind of covering them up and putting a Teflon disc, a thick Teflon disc here. And what's going to happen is that Teflon disc is going to have the ability to move up and down and kind of compress grease to a set thickness. So what we'll do is, and again, I think what it is, the 0 is the D thing. I would read my instructions. You'll have to double check me. But I'm going to raise this up and place this in place and bring it back down. Now that's a set thickness. It's my zeroing thickness for this device. And now I just want to set at 0. I'm going to pull the handle down, and when it moves up into this top position, this is where I'm going to lock in. So when the handle goes down, it's going to lock in at 0 for this position. So I use this to tighten in that position.
So there's kind of like a locking nut on the other side of here.
Yeah.
And that's going to set the position.
So that's 0 position. And there's some instructions where you can check this and so forth. But now I've got a gap. Actually, I missed a step. So we're going to redo it. I need the spectrometer from the kit.
Is that this fancy thing? What is it?
Yes, it is.
Okay.
So let's open that up. So this is a spectrometer, a visible light spectrometer.
I don't want to do this without just damaging something. Oh, here we go.
Yeah. Cut it in half there and pull that out. and it looks like a diamond or a gem sitting there.
Yeah.
Yeah. And so let me just show what you have here. This is the spectrometer. This is the window that will introduce the light, and also the reflection will then be captured in here for analysis. The only other thing that you have here is just a power cable. Okay. It's also could be used as a communication cable, but we're just going to use that to charge this up, and it's 12 volts, and when it's charged up, it's running completely wirelessly. So now what I'm going to do is I'm going to pick this up, place this on that base, and go 0 from here.
Okay.
Because now I want to bring that down.
And then we're going to tighten that?
Not yet. One more step. In these small boxes is the adapter for that. So if you pull one of them out, there should be several. And this is a window that makes it, not that one, let's see. There should be another one. Let's see what we got. Are they all the same? These are all the same.
That's a power.
There should be a little flat black adapter for you. It's not in that. How about in that bag?
What's this
Is
thing?
there a bag there? We might be this bag here. Let's see.
Oh. Now the advantage of recording this is that I'm then going to be able to use this as reference when I need to rebuild this thing at home.
Okay, it's not there either, but we can proceed. This is a good check before you go home. It's not. That's going to be the calibration reference.
Oh, okay.
Where we're going to stick that right on there to calibrate it. But I think what we may be missing here, I'll make one more look, Rafe, into this box and see. Nope, that's just another kit for you. So we may be missing one piece that we will go ahead and make sure that you get before you take this back again. And it's an adapter, so I can kind of illustrate what it is. And so there's a piece that fits right inside of here, becomes flat, and has a window over that, because we're going to put grease right onto that surface.
Oh, okay.
And that's where we're going to squeeze it out. So again, I'm going to pick this up. We're going to proceed as if that piece is on there. And from there, now we're going to make our 0 point, because we want to bring this down and squash grease at that location to the set distance. This is the 0 distance. Okay, so that's in place. Now we're going to be removing this 0. Yep. We'll go down to the one that's the smallest in the group, that's going to leave 0.035 inches of space when it gets squeezed into that space. So again, now we're going to take this and put a dab of grease right on here. It takes something like 1/10 of a gram or even less than that. And then we're going to squeeze this down. And at that position, you're now creating that film at 0.035 or about 1 millimeter of thickness. And then we can use our app, we can use a smartphone to communicate with this, turn it on, measure the spectral response, and use that as the value for the grease.
Okay, so then when we get values for the grease, I guess, in my conception of this, this is kind of like the equivalent of MPC testing.
Yes,
right?
It's very close to that. In fact, we're using the same sort of measurements with the CIE values.
Yeah.
And we're going to create the CIE values for the reference grease. So in MPC, you can show your patches there, right?
So if anyone has done MPC in the past, you would know that you kind of develop a patch. This is not actually an MPC patch, this is a micro patch, but similar kind of thing, right? And what we do is, in hydraulic and turbine and compressor oils, we are measuring the color values of these patches, and that gives you an indication of degradation of the oil, also its propensity for varnish.
Yeah.
We kind of use it as a varnish potential. So MPC stands for membrane patch colorimetry.
Right.
And here we are doing, I guess, a version of grease colorimetry.
Yeah, it's what it is. And you're right, the baseline is a white patch, and then you're measuring against that, or you're looking at a delta value, right? Here we're going to do this once with the fresh grease, the reference grease, and that will be our 0 point.
Yep.
And then we compare that to the grease. So we'll get a delta E value out of the software for this spectrometer.
And as it relates to used grease, what kind of degradation are we measuring using this?
So this is really a composite measurement, because there's multiple things that could be changing the grease color. One example would be the wrong grease, which has a different dye, and it shifts that spectrally. So it may not be much darker or lighter than the grease that you started with, but it's shifted into a different hue.
So that's an indication of contamination.
Yeah, that's an indication of grease contamination, and that'll be primarily seen in the A star and B star values for those who are familiar with that measurement. The L star value is more about the lightness or darkness of the sample. So as another example, as the grease would maybe be subjected to heat and oxidation stressors, it's going to tend to have that same core color that the dye is, but it's going to be shifting into the darker regions. So you would see L star values being the primary contribution to the delta E values.
Okay.
There might be other situations as well. There could be water contamination. In grease, I have found that it has to be really bad, like tens of thousands of ppm before it changes the appearance of the grease noticeably.
Okay. But you'll also see that, so as part of this mini kit, my plan is to also run like an an FTIR or a direct infrared test on the grease. So you'll get an indication of water content from the IR sample,
gross
right?
water, yeah.
And so this would almost be confirmation of water.
Correct.
So I mean, that's one of the advantages of this is being able to kind of do grease degradation on multiple dimensions, right? Out of one test.
Yes.
Okay.
And it's more of an index. This is meant to be like, it's really good for a screening test, like, because I'll tell you what, the inspiration behind this actually happened with a robot technician who works very close to our lab. And I went to that company, I said, can I tag along as you do maintenance on the robot so we can gather some grease samples? And so he did, he brought me along, and at the end of the day, he said, I said, I'll share with you the results of the analysis. And he goes, well, you're gonna find problems with the 3rd, the 5th, and the 8th robot we saw.
Yeah.
And I was like, how did he know that? He's not even taking any measurements. And he goes, I can just look at the grease and I could tell.
Yeah.
And so right there, that told me that there was a visual indication, and he was exactly right, by the way. There's a visual indication that tends to correspond to the degraded condition as borne out by somebody who has done thousands of robot maintenance activities. And so I said, not everybody can have Ben's sight because they don't have that experience. So let's give them a way of measuring it and some criteria around which you can say that's a normally expected variance for robot grease or whatever grease. And beyond that, now we dig deeper to find out what the cause is.
Now maybe that's one thing to highlight as well, just in terms of general maintenance and reliability, the value of a good technician.
Yeah.
Right? I think that, certainly in my markets, I don't know about everyone else, lube technicians, way undervalued.
Yeah,
right?
For sure.
Aren't paid very well, tend to be sort of bottom of the totem pole, right, when it comes to the hierarchy in the maintenance team. And yet, these are the guys who, when they're doing their lube rounds or their re-greasing routes, are touching, feeling, smelling, viewing the machine and the grease on a more consistent basis than anyone.
Yeah.
And when we think about oil analysis or grease analysis, and we're doing trending, right, the importance in trending is getting enough data density that you can see the trends.
Sure.
And you can see deviation, right? And because these guys might see a specific bearing once a day, in some cases, they are in many places best placed to see those trends. And so you want to empower those guys, beyond this,
right?
Even just to flag,
sure,
hey, the oil smells different today.
Yeah.
Right? They're the ones that will pick that up.
Right.
So, the lube technicians, when you have a good one, you hold on to that person.
Yeah, and let's be honest. I mean, if that lube tech says it doesn't look right to me, they're probably not going to get the confidence of the decision makers in the facility to make major, changes or shut things down and whatnot. So, in a way, this becomes the numerical backup to that, and you can create over time what the appropriate action criteria are that correspond to a measured parameter. So our whole focus with this is, things look different, and anybody who works around grease a lot will say, that's darker, that changed, that's not what I expect. It's like if you're the guy with the grease gun and you're pumping blue grease in, and you see purple grease coming out, you can kind of put 2 and 2 together, but what you have here is a numerical value that's going to be put against a criteria to say to the decision makers, this is actionable.
Yeah.
Because there's data with it. And that whole necessity becomes even more important as we see, Industry 4.0 and 5.0 and the use of sensors, where it seems like, a lot of decision makers are ahead of all that. They're like, where's my sensor? Where's my data? So we fulfill that. But we still recognize that the technician that knows this is in really good position to pick some things up as well.
Yeah, that's awesome.
Yeah.
Now maybe just getting back to this is mine, my little my new toy.
Yeah.
You've got a bunch of spaces here.
Yeah.
What would I use the B and the C spaces?
The B and the C. So we know that the D was the 0, then the A becomes the larger 0.035. The issue is that if you have a grease that's very, very dark,
Yep.
you're not going to be able to see anything through it. It's just, black is black kind of a thing. You have to thin that grease out more to get a response. So at the start, we don't necessarily know how thin we need to make this to get a measurable parameter. So I started with 0.35, but now if that would give me kind of a 255, 255, 255, or whatever the max out is, then I would remove this spacer and I would go to the next one, which will take it from what was done on there at 0.035, and now it's going to take it to 0.010. And by pushing this down, that's what I have as the gap now.
Right.
And if that's not enough, we go one length further. So when I started doing colorimetry, I was getting too many greases that were, too black to know what's going on, but something's not right. This takes us to that second and third level. The reason we don't always go to that level is because if a grease is rather translucent, the light will overwhelm the sensor. So we do need to vary the thickness to get that area of measurement capability by using the spacers.
Okay, makes sense. Makes sense.
I also threw another bonus in there for you too,
Ooh.
which is those little white boxes that we were looking at. And if we open up one of these, this is a liquid cell. So there is a little cover on here that we can pop off, and then we can put a couple drops of oil, coolant, whatever liquid we want to measure, and that can also be tested with this device.
Oh.
So yeah, so you're going to get, colorimetry capabilities for the other lubricants that you're testing as well.
Awesome.
Yeah.
Bonus.
Bonus.
I love free bonuses.
Right.
It is free, right?
Yeah, sure. For one price, right?
Yeah.
Yeah, so what we can do, Rafe, is we can kind of bundle this back a little bit.
Yep.
And move on to the other one so we can continue and...
Okay, so I got to get the other box out?
Yeah, let's get
Yep.
the other box.
All right. So this is the goodie.
I'm curious now because you said you're getting a grease tester. That's my background.
Yeah.
Yeah.
So we're podcasting live right now on this demonstration.
You're live.
Yeah. And it's so interesting that people are stopping at the booth and asking us about it. So yeah.
So we got Mike here, Mike McCabe. If anyone needs help with Amazon or e-commerce for engine oils, he's your man. He's your man.
Nice.
All right.
Nice.
Now,
Yeah.
okay. So this is the Poseidon FerroQ. So now, if anyone's heard of like PQ index, FerroQ is where it's at. So ferrous debris kind of analyzer. I guess the advantage of this one over the PQ index, which we're used to, PQ index just gives you a number, which is a frustratingly has no units.
Abstract.
It's abstract.
Dimensionless.
Like, I don't know, is the number 50 good, bad? People don't really know. Here, we're going to get a ppm value, which is awesome, right?
Yeah.
So, anyway, so hopefully people can see.
So yeah, this can be used both for oils and greases. These are some of the vials that we've gotten together for you, Rafe, for liquids. And there's going to be a little collar in there, and then this is a 2 milliliter vial, and that'll go right in there and measure for the liquid oils.
And these are the standard,
Yeah.
I'm assuming?
Yep.
So it's got a number on the top, 522, which I'm assuming refers to parts per million.
That is correct.
And so the idea is I drop this in,
Yep.
and if I measure it, it should show up as 522.
That's correct. It's a confirmation of calibration, which is always important. We need to periodically confirm that our calibration is still in effect.
Yeah, awesome.
Yeah.
Awesome. So this is the other part of the mini lab.
It
right?
is. And so, of course, we're talking grease. So we showed the oil. Let's show the grease as well. So didn't we mock fill a grease thief just a minute ago for the camera, right? So where did we lay that one down? Or we put it right back in the bag?
Oops. So, but we still have it inside
In
of
the
its
tube, right?
container.
Yeah.
So when it gets shipped, it should come to me, that is the lab, it should come like this, right?
Right.
So we're gonna, I guess, open the stopper, take this out. Now what do I do with it?
So now you have this filled with grease, and it's that simple. It drops right in there.
Oh, okay, I totally misunderstood that. Okay, this is good for me. I'm learning on the fly here too, because I thought I was gonna have to deposit the grease into one of these.
No, which is nearly impossible. This is the problem. And when you look at a lot of instruments and a lot of methods that have been developed for grease, grease gets treated as a slightly thicker cousin of oil, which is really not valid. And anybody who's tried to fully fill some kind of container with grease will get very frustrated. There'll be pockets, and because the air doesn't just float to the top like it does in oil. There's fundamentally different. The second part of grease that's much different than oil is that we can't shake it up.
Yeah.
Now, if you have an oil sample bottle, you can shake it up, you get it homogeneous, you aliquot that, and then that's what you analyze. Can't do it with grease. And so over time, we worked with Poseidon to develop this sensor so that when you do this insertion, it's a dynamic measurement. It measures it as it goes in and then correlates that to the total amount of ferrous from top to bottom represented as a ppm value. We've tried using grease on other kinds of instruments, and there's a spatial bias.
Yeah.
They are designed to assume that it's oil and it's been shaken up and that it's homogeneous. But grease, you can't get there. So we have to use techniques and instruments that account for that heterogeneity.
Hey, I actually got just a question from Jared over on my channel. Hey, Ray from Reg, thanks for the live stream. Curious, will there be a difference in the procedure or setup when dealing with a moly or graphite in grease?
And is he going back to the color?
Well, let's answer it for both.
Yeah,
so if we've got a moly or graphite grease, I guess the grease itself is dark. It's probably what that's referring to, right? So most of those greases are black.
Right.
Does that make a difference to the colorimetry?
It does make a difference to the colorimetry. So the kind of the blind spot, if you will, on the colorimeter is something that completely blocks light transmission. So if you have enough moly or have enough graphite in a sample, when you even take it down to that 0.05, you may not get appreciable light transmittance through there. And so at that point, it's not extremely helpful. Although if it was mixed with something that was not that grease, lighter in appearance, you may actually get some light coming through. So it's more of that difference to the baseline. It's worth a try, but we do occasionally encounter greases where we just say, we're not getting actionable data from the colorimeter because black is black.
Yeah. Okay. So I guess my plan with the mini lab is, the idea is, moly and graphite greases, kind of different, but as part of like setting up this kind of lab or mini lab that I'm talking about, you would actually be able to test what using the infrared, you'd still be able to get a measure of degradation.
Yeah.
And you would still also be able to test, that would give you water. You could use this still for ferrous density, right? Because it wouldn't make a difference.
That is correct. It doesn't make a difference there.
And I don't know, well, you probably could do, this would cost me a lot more money, but if I did RDE, you could still get elemental analysis.
Absolutely, yeah.
If you did.
Sorry to interrupt you. I'm Zach.
Oh.
Zach Walsh
Hey,
from
Zach.
Firefly. Rafe, nice to meet you.
How's it going?
Okay.
Rich, right?
Yeah, we're
Yeah.
broadcasting live right now.
Oh,
Yeah.
Come on in.
no, that's all right.
No.
Get you
I'll
a
come by.
badge.
Thanks. Yeah.
So you'd still be able to do all of those tests, and you'd be able to do, well, if I do XRF, you probably couldn't on a grease though, right? Because you run into the same homogeneity problem that you do with PQ index.
The actual calibration for the grease matrix is pretty challenging if you want to get like that accurate representation.
Okay.
What we have done with XRF is post grease thief analyzer, where we've squeezed the grease out into a thin film, and it kind of reduces the heterogeneity in the sample somewhat.
Oh, okay.
Yeah, so there's some advantages down the pike when you get to that. But no, I mean, sometimes it's just the ferrous itself is really helpful for that. We just need to know where, if you don't pass light, then there's nothing for a colorimeter to do.
Yeah, okay.
Yeah.
Oh, cool.
Yep. So, and then of course you can follow up when you find those greases that are outliers, or you may have a grease that you say it's not I really need to know about that, and the colorimetry doesn't tell me. So I put that into the follow-up test regimen as well. Yeah.
Okay, cool. All right, I think that's pretty much everything, right?
Yeah, I think it is, and maybe we'll see if there's other questions. I mean,
Yeah.
Sonia's been looking here. Did you pick up any other questions there, Sonia?
I didn't pick up any other questions just yet because I think a lot of people are just interested in the unboxing and just really getting that, that extra feel and actually knowing that the grease teeth can, be set up anywhere.
That's
in
right.
this mini lab.
Including
Literally on the top of a table.
including Oz, right? The land of Oz. It's headed down under next, which is exciting. Yep. And really that's important too, because Sonia, think about what this podcast series has really been about. It started for KSA, for the Kingdom of Saudi Arabia, because there wasn't really options in that part of the world. And now we've really evolved to a point where, other labs can decide to do that. But in the meantime, we don't have to wait for that. We can get set up with a mini lab in our facility, or work with somebody like Rafe if that's your area of the world, and you could just send the samples to him. So we're really trying to make grease analysis more accessible to folks.
Hey, we got a question actually on the YouTube channel, and I've seen Ahmed also had a question on LinkedIn Live, so we'll try and address both. So Cheeseburger XJ, great username, asked, how does 3% moly grease work for low-speed, high-load tractor wheel bearings? Well, Rich is a farmer, extensive experience with grease on farm equipment.
Yeah,
You're going to have way more authority than I am here.
Yeah, I got to say that I have not done a lot of maintenance on the tractor wheel bearings at this point, but it's probably because of usage, right?
Yep.
If I was full-time, I'd get more usage. I've got this side job that involves grease, so I don't get to farm as much as some folks do. But yeah, you think about the application, and what I always do is I start with the OEM and see what the OEM is saying about that. There may be reasons not to use or start with a moly. It may have to do with clearances and things like that. It may be unnecessary depending on the application, but you always want to go back and look at your reliability and cases of failure and question that guidance. And what the moly grease really does for us is it adds another mechanism for lubrication. You have the viscous film, but if the viscous film isn't maintained, you've got the moly there as a solid additive as well. And so in some kind of severe applications, it might make sense.
Yeah, so in general, I mean, moly greases, especially 3%, 5% moly greases, really common in mining applications. Mm-hmm. And I would expect for low speed, high load tractor wheel bearings, right? That's kind of where the solid lubricants shine. Yeah. So whether it's moly, graphite, PTFE, all of those kind of solid lubricants, that's where they come into their own. So, without knowing the exact specifics of your application, I'd say, it'd probably do pretty well.
Yeah, and you do, like in a tractor, you could be slow moving, plowing in a field, or you could be out on the road trying to cut your transit time to the next location. So you can get some decent speeds going, and that's application specific we'd have to look at. Yep.
Yeah. Now, Ahmed has also asked, can we test all NLGI grades? So 000, all the way through to 4 or even a 6?
Yeah, so it's a great question. The challenge for the really thick greases, or possibly the thinnest greases, is can I get it into a grease thief and will it stay in there, like the really thin stuff? And I have done double aughts. I don't know if we've tested triple aughts too much with the grease thief, and just in terms of it being a container to hold it in. But down to double aught, it's fine. And you just may have to be a little more aggressive in the force required to get it from the location into the grease thief for some of the heavier greases.
Yeah.
But it's a matter of patience, really. It's like when something is that thick, viscous, high consistency, you just can't rush it. You just have to push slower, and you get a slower rate of fill or transfer into what you're doing. So like you just demonstrated a few minutes ago with the GT filler, you could get that grease in there, and it would just be a slow process probably to get it into the grease thief.
Yeah.
So the answer to that part of it is yes. If you go to the ASTM standard D7918, specifically for die extrusion, and we didn't talk about this a lot in this discussion, but that's an extrusion die on the end of a grease thief, and you would just push that through. It's pretty thin, and I believe that method is from 0 or grease zero aught greases up to NLGI 3, but not beyond.
Okay. And as Ahmed has already pointed out in his question, I mean, NLGI 2 and 3 are far and away the most common.
Yeah.
I mean, I do see a lot of zeros and ones in mining applications, especially in centralized, lube systems, or centralized greasing systems.
Yeah.
So yeah. Cool. Hey, maybe another couple from the YouTube channel. Moly is good for extreme pressure. Yes. Yep.
True.
So in anything low speed, high load, absolutely.
Yep.
Ahmed has asked us a question about an engine oil. Not super relevant to the discussion we're having at the moment, but let's see, Liquid Moly Ceratec help new engines run smoother. Can I use it on a Mercedes C300? Okay, right. yeah, maybe not super relevant to the grease thing. However, let's just address it because that falls under the bucket of engine oil additives and post-treatment additives and all that sort of stuff. A few people have different opinions on this, right? I would say in general, it's not going to hurt, right? For new engines, are you going to see a huge amount of benefit by putting in an aftermarket additive? Personally, I don't think there would be a huge amount of benefit in doing that. I have seen it improve in some like really, really old engines, where you're starting to have, a bit of noise on the tappets and things like that, just a bit of noise reduction, maybe a little bit of reduction in sort of timing chain wear and things like that. Personally, I wouldn't use it on a new engine, right? Another question, and I think this was related to the solid lubricants, is hexagonal boron nitride a good lubricant? Because if you look it in a microscope, it looks very sharp. Thank you. Do you have any experience with HBN?
Have not worked with them much, yeah.
Okay. So I've seen a little bit of HBNs actually in liquid dispersions in oils, as well as HBNs in greases. So one thing to be really careful of, there's two different types of boron nitride. One is cubic boron nitride, the other one is hexagonal boron nitride. There's basically different crystal formations, right? So it's the same as in, let's say, for example, calcite. Right, there are like 6 different types of calcites. So, in calcium sulfonates, again, only specific types of those calcium crystals are going to be really good in extreme pressure scenarios. Now, hexagonal boron nitride, it does look sharp, right, under the microscope. However, because it has those what we call atomically thin layers,
Fracture planes.
Fracture planes and a very, very sheer, very, very low shear strength between those planes, that it acts as a really, really good solid lubricant. HBN is particularly useful at very, very high temperatures. So when you start to exceed like 450-ish, that's when moly starts to kind of get a little bit sketchy, and that's where we might enter that sort of region where we use HBN. So, relating it back to the grease discussion, some of the very high temperature greases will often use HBNs. Cheeseburger has followed up. I stay below 5 miles an hour using Valvoline Moly 3%. Okay. Yeah, makes sense.
Yep.
Makes sense. All right. Alan is like in Detroit. Alan, come by and say hi.
Didn't even know that. Well, hey, I think we covered a lot of good ground here. How do you feel about your new capability here?
Yeah, good. So this is all part of me trying to set up like a miniature lab in Australia for kind of root cause type investigation. One thing I'm really passionate about is this kind of grease testing. Again, everyone's doing oil analysis, not necessarily well, but they are doing it, right? And I'm really trying to push this idea of, hey, grease is just as important as oil to reliability, so why are you not testing your greases? So that's kind of my objective in getting this up and running. It seems, let's call it idiot-proof, right? And you're looking at a perfect example of an idiot here. So if I can do it, anyone can do it.
Yeah.
Right. Oh, Sonia's joined us.
Came across.
Yeah,
Very
awesome. All right, so Sonia's actually been monitoring the chat the entire time. So appreciate her helping out with the live stream.
For sure. So thank you, Rafe,
No, thanks, Rich.
for joining. This is the first ever dual podcast, I guess we would say. And it's the first ever with members in person, which is really cool. And so we'll continue again. We'll get to doing this next month. we'll be watching, Rafe, your channel, with interest, as we always do, because you always cover a lot of good topics, and maybe we'll get some crossover on some of our audiences here. But watch Rafe in the coming months for him to bring the grease thief and grease analysis to Australia.
Yeah, I'm really excited to get set up.
Super. All right. Thanks.
Awesome. Thanks, guys.
All right. Signing off from Detroit.
Catch you later, guys.
Yep.
Hey, and just for my live stream, I've seen a couple of questions just come in. At what temperature does silicon grease resist before it turns into a liquid? I want to use it on a transmission gear linkage. I actually don't know when silicon turns into a liquid. I'd have to look that up in terms of temperature. Also, some of the silicon-based greases are really good as well, so you might want to consider that, right? If you're concerned about it turning to liquid and running out of something, obviously the grease is designed to hold that liquid in sort of like the thickener matrix. And Cheeseburger, thanks for making all the oil videos. Hey, no problem, mate. Really excited. I always really like to just kind of share this information. And the best thing about this channel is you get to access to actual like real experts. I'm like a pretend expert. This is like the real expert when it comes to grease. And Sanya is, has also featured on the podcast a couple of times, is the expert on varnish formation. So that's what I really enjoy.
We're closing the loop, right? Because I was first.
Yeah. Rich was actually the first, the very first guest on the podcast. So
it's good to be back.
Yeah. It's been really good.
All right.
So
super.
hey guys, I will try and upload another video or something at the end of the week, but we'll see how we go. All right. Thanks guys. We'll talk soon.
Bye now.
I actually